hear me, guys, or you can't hear me? Hello? Can you hear me, guys, or you can't hear me? Hello?
REST API. What is a REST API? Well, think of REST API like a waiter at a restaurant. You tell the waiter what you want, they go to the kitchen, get it, and bring it back to you. That's exactly what a REST API does between your app and a server. REST stands for Representational State Transfer. Fancy words that basically mean a simple way for applications to talk to each other over the internet. REST uses the same HTTP methods you already know from web browsing. Get to retrieve data, like asking show me all users. Post to create something new, like add this new user. Put to update existing data, and delete to remove it. Let's say you're building a social media app. When you want to show user profiles, your app sends a GET request to something like api.myapp.com/users/1. And boom, you get back all of John's profile info in a nice, clean JSON format. REST is stateless, means each request is completely independent. The server doesn't remember your previous requests, which means it can handle millions of users without getting confused about who asked for what. REST is also platform independent. Your iPhone app, Android app, web app, and even your smart fridge can all talk to the same REST API. But REST isn't formal enough for your bank transfers and enterprise systems. That's where SOAP API comes in. SOAP API, SOAP, or Simple Object Access Protocol, is one of the oldest and most formal ways that systems communicate with each other. If REST is like a casual phone call, SOAP is more like a formal business contract. Every message must follow strict rules and comes wrapped in XML with a very specific structure, an envelope to wrap everything, a header for metadata, and a body that holds the actual request or response. One of SOAP's strengths is that it's protocol independent. While it's most commonly used over HTTP or HTTPS, it can also run on SMTP, TCP, or other protocols. And because it has built-in standards for error handling, security, and transaction support, SOAP is often trusted in industries where reliability and precision matter most. That's why banks, healthcare providers, and government systems still often trust P or other protocols. And because it has built-in standards for error handling, security, and transaction support, SOAP is often trusted in industries where reliability and precision matter most. That's why banks, healthcare providers, and government systems still rely heavily on SOAP today. For example, when you transfer money between banks, there's a good chance a SOAP API is working behind the scenes, ensuring the transaction is secure and correctly processed. SOAP might not be as lightweight or flexible as REST, but when you need guaranteed delivery, strict contracts, and enterprise-grade reliability, SOAP is the go-to choice. gRPC API. Before we talk about gRPC, let's step back to RPC, or Remote Procedure Call. RPC is the idea that instead of sending raw data over the network, your app can directly call a function on another machine as if it were local. For example, you write getUser123 in your code, and behind the scenes that request travels across the network, runs on the server, and returns the result. But early RPC systems like XML RPC or JSON RPC had problems. They were slower, text-heavy, and didn't scale well for today's massive real-time apps. That's where gRPC comes in. gRPC is Google's high-performance modern take on RPC. Think of it as the Formula One race car of APIs, built for speed, performance, and precision. While REST sends text-based JSON over HTTP, gRPC uses protocol buffers or protobuf, which compress data into a compact binary format that's lightning fast to process. It's like the difference between mailing a handwritten letter versus zipping all your files and sending them instantly. gRPC also takes advantage of HTTP2, allowing multiple requests to run over a single connection at the same time. And here's the best part. gRPC supports 4 powerful communication patterns. Simple request response, just like REST, server streaming for live updates, client streaming for sending continuous data, and bidirectional streaming, where both sides can chat at once in real time. The performance gains are massive, often 7 to 10 times faster than REST in many scenarios. That's why gRPC is the secret weapon behind systems like Netflix, Uber, and high-frequency trading platforms. GraphQL API. GraphQL stands for Graph Query Language, and it's about to change how you think about APIs forever. Created by Facebook, GraphQL is the game-changing query language that's revolutionizing how we fetch data. Here's the problem that GraphQL solves. In the case of REST APIs, you often get too much or too little data. Need a user's name and email? REST might send you their entire profile, address, preferences, and shopping history. That's called overfetching, and it wastes bandwidth. Or worse, you might need to make multiple API calls to get everything you need that's underfetching. GraphQL flips this completely. You write one query asking for exactly what you want, like just give me the username and email, skip everything else. One endpoint, one request, perfect data every time. But the killer feature of GraphQL is real-time subscriptions. Your app can listen for live update automatically. Plus, GraphQL is self-documenting with a built-in playground where you can test queries instantly. Skip everything. GraphQL flips this completely. You write one query asking for exactly what you want, like just give me the username and email, skip everything else. One endpoint, one request, perfect data every time. But the killer feature of GraphQL is real-time subscriptions. Your app can listen for live update automatically. Plus, GraphQL is self-documenting with a built-in playground where you can test queries instantly. GitHub's entire API is built on GraphQL. Shopify and Pinterest all use GraphQL in production. If you're building modern applications where performance matters, users are on mobile devices, and you want to give front-end developers the flexibility to request exactly what they need, GraphQL might just be your new best friend. But sometimes you don't just want to fetch data. You want to be notified the instant something changes. That's where webhooks come in. Webhook API. Imagine this. With most APIs, your app is like someone constantly checking their mailbox. You walk outside, open it, see nothing, and walk back, over and over again. That's how traditional APIs work. Your app has to ask the server every time it wants to know if something new happened. But webhooks flip that model completely. Instead of you asking, the API calls you. It's like the mailman ringing your doorbell the moment the letter arrives. Instant, direct, and efficient. Let's see how it works. You set up a callback URL in your application. Whenever an event happens, like a new payment,
Yeah, I'm ready for this week's 20 hours I can work. So totally can work in days. Once and be ready, like mid-level or anything you want. Or after it.
a code push, or a form submission, the service sends a post request with the event details straight to your callback URL. No polling, no wasted requests, just real-time updates. That's why webhooks are often called reverse APIs. Instead of your app chasing the data comes chasing your app. You'll find webhooks powering nearly every modern application. Like GitHub fires webhooks when new code is pushed. Shopify triggers them when an order is placed. Slack and Discord bots rely on webhooks for commands and real-time reactions. From automating workflows to keeping systems instantly in sync, webhooks are the invisible backbone of real-time web development. WebSockets API. WebSockets are like opening a permanent phone line between your app and the server. Once the connection is established, both sides can talk to each other anytime. Instantly, no more waiting for the client to ask a question like with traditional HTTP. Here's how it works. It starts with a handshake. Your browser sends a special HTTP request saying, let's upgrade this to a WebSocket connection. The server agrees, they shake hands, and from that point on, the channel stays open. This gives you a persistent two-way communication line, which is perfect for real-time applications. Unlike regular HTTP, where the client always initiates, WebSockets allow the server to push data to you the moment something happens. Think about getting a stock price update, a chat message, or a game event the instant it occurs. That's the power of WebSockets. And it's flexible too. You can send plain text, JSON for structured data, or even WebSockets allow the server to push data to you the moment something happens. Think about getting a stock price update, a chat message, or a game event the instant it occurs. That's the power of WebSockets. And it's flexible too. You can send plain text, JSON for structured data, or even binary files like images and videos. WebRTC API. WebRTC, or Web Real-Time Communication, isn't just a single API. It's a full framework that enables direct peer-to-peer communication between browsers or mobile apps. And here's the magic. The data doesn't need to flow through a central server. That's why WebRTC powers things like video calls, screen sharing, online gaming, and instant file transfers, all happening right inside your browser with no extra software. Think about your last Zoom or Google Meet call. When you're talking, your video and audio are sent straight from your device to the other person's device. No server in the middle storing or processing your private conversation. It's direct and real-time. Behind the scenes, WebRTC takes care of the messy networking details. It figures out NAT traversal so devices can talk across different networks. Think about your last online gaming. Isn't just a single like images and videos. WebRTC API. WebRTC, or Web Real-Time Communication, isn't just a single API. It's a full framework that enables direct peer-to-peer communication between browsers or mobile apps. And here's the magic. The data doesn't need to flow through a central server. That's why WebRTC powers things like video calls, screen sharing, online gaming, and instant file transfers, all happening right inside your browser with no extra software. Think about your last Zoom or Google Meet call. When you're talking, your video and audio are sent straight from your device to the other person's device. No server in the middle storing or processing your private conversation. It's direct and real-time. Behind the scenes, WebRTC takes care of the messy networking details. It figures out NAT traversal so devices can talk across different networks. It automatically negotiates the best audio and video formats. And it uses adaptive bitrate streaming, which means it constantly adjusts quality depending on your internet speed. The result? No server bottlenecks, faster communication, and smoother real-time experiences. That's why WebRTC is the backbone of modern video conferencing, real-time collaboration tools, and peer-to-peer apps.
Oh, it was so cool. I liked basically.
Git is the foundation of any software development workflow. Think of Git as a time machine for your code. Every time you
No, I don't like this. It was basically cool. I like that. So, if I wanna go for first YouTube video, it's don't become a dosager, do this instead. Oh, whatever bullshit. Every programming language explains 16 minutes. Oh, that's not bad.
Python. Created in 1991 by Guido van Rossum, Python had one job: make code readable. No curly braces, no semicolons, no sacrificing a goat to compile your program. You write logic almost like English, and it just works. Because of that clarity, Python quickly became the go-to language for beginners, educators, and professionals who wanted to get things done fast. Today, it's one of the most popular languages on the planet. From automating small tasks to powering billion-dollar applications, Python is everywhere. What really makes it powerful is its ecosystem. Python has a library for almost anything: NumPy and Pandas for data analysis, TensorFlow and PyTorch for machine learning, Flask and Django for web development, and countless smaller packages that handle every niche you can imagine. Companies such as Netflix, Spotify, and NASA rely on it daily. Netflix uses Python to manage recommendations and video streaming, while NASA uses it in their equipment control systems and simulations. Python's versatility is unmatched. You can use the same language to analyze satellite data, build a web service, and write an automation script that renames your files, all before lunch. And because it's open source, the community constantly expands it. Thousands of developers contribute to new tools and libraries every year, which is why Python continues to evolve faster than almost any other language. Of course, Python has a dirty secret. It's slow, like really slow. C++ developers look at Python code the way Formula One drivers look at golf carts. But here's why nobody cares. Python gets you from idea to working product faster than any other language. A task that takes 100 lines in Java can be done in 10 lines of Python. It's like comparing building a house with Lego versus carving each brick by hand. More importantly, Python scales with the average user. You can start with basic scripting, then move into full stack development or AI without ever switching languages. It's accessible to newcomers, but deep enough for experts. C++. C++ is the language that can do absolutely anything and will absolutely let you destroy everything. It's the programming equivalent of handing someone a chainsaw, a flamethrower, and a nuclear reactor saying, "Good luck," then you destroy everything. It's the programming equivalent of handing someone a chainsaw, a flamethrower, and a nuclear reactor saying, "Good luck," then walking away. You have the ability to decide how every byte of memory is used, and the ability to optimize down to the nanosecond. You also have the ability to accidentally corrupt your entire program because you forgot a semicolon in line 847. Two developers can write the same program in C++ in completely different ways, both be correct, and both be impossible to read. By the mid-1980s, software was getting massive. Programs weren't a few pages of code anymore. They were entire novels. And writing all of that in plain C was starting to feel like performing brain surgery with a screwdriver. Born in 1985 as C with classes, C++ took everything fast about C and turned it from chaos to organized chaos. C++ introduced object-oriented programming, allowing developers to bundle data and functions together into objects. It might sound obvious now, but back then it was revolutionary. Suddenly, you could design software like a system of small, organized components instead of one giant mess of logic. By the 1990s, C++ was everywhere. Microsoft Windows, Photoshop, Autodesk Maya, and Mac OS all used it. It powered desktop software, operating systems, and the first generation of 3D games, and it still hasn't gone anywhere. The Unreal Engine, which runs games like Fortnite, PUBG, and Final Fantasy VII Remake, is built on C++. So are major parts of Google Chrome, Amazon's back-end systems, and Facebook's core infrastructure. Basically, if something is fast, reliable, and important, there's a good chance it's quietly powered by C++. It's also a favorite in finance and telecommunications, where performance isn't just nice to have, it's non-negotiable. When a trading system can lose millions in a millisecond, fast enough means written in C++. But with great power comes great confusion. C++ gives you a massive toolbox. Classes, templates, inheritance, operator overloading. It's not that C++ is hard. It's that it gives you so many options you end up debating yourself at 3 a.m. about which one is technically better. Quick question. Which of these languages frustrates you the most? Drop it in the comments. I'm genuinely curious. All right, let's talk about Java, the language that refuses to die. Java. Java is the programming language equivalent of a middle manager who wears a tie to Zoom calls and has been running Fortune 500 companies for 30 years, and he's not going anywhere. Born in 1995, Java promised the impossible. Write once, run anywhere, and for the most part, it delivered. Anywhere. Born in 1995, Java promised the impossible. Write once, run anywhere, and for the most part, it delivered. In C, you print static void main method, importing system.out, and basically writing a legal document just to say hello. But that structure has a purpose. When you're managing a code base with 50 developers across 10 time zones, Java's verbosity becomes clarity. Everyone writes code the same way. No surprises, no creative solutions that break everything. That's why banks love it. Airlines love it. Governments love it. Because Java code from 2006 still runs today and will probably outlive us all. Instead of compiling straight to machine code like C, Java runs inside the Java Virtual Machine, or JVM, a sort of universal translator that lets the same program work on Windows, Mac OS, Linux, or even your smart fridge. It might make your laptop sound like it's taking off, but it'll run and keep running. Boring, reliable, and absolutely not going anywhere. That's Java. JavaScript. If programming languages were people, JavaScript would be the unpredictable friend who somehow gets everything done, even though no one understands how. It was created in just 10 days in 1995 to make websites interactive. Today, it powers now gets everything done. That's Java. JavaScript. If programming languages were people, JavaScript would be the unpredictable friend who somehow gets everything done, even though no one understands how. It was created in just 10 days in 1995 to make websites interactive. Today, it powers 98% of the web, handles front-end interactivity, and thanks to Node.js, even runs servers. Even this video you're watching is most likely using JavaScript somewhere behind the scenes. Here's the catch. JavaScript makes no sense. Developers call it a forgiving language, but they really using JavaScript somewhere behind the scenes. Here's the catch. JavaScript makes no sense. Developers call it a forgiving language. What they really mean is that it silently lets you destroy everything without throwing an error. But despite its quirks, or maybe because of them, JavaScript became unstoppable. Every major website, every online tool, every front-end framework is built on it. React, Vue, Angular, Next.js, you name it. The real magic? It runs natively in every browser. Performance-wise, JavaScript isn't the fastest, but the modern V8 engine built by Google turned it from toy language into a legitimate powerhouse. You can build real-time apps, 3D games, and even back-end APIs entirely in JavaScript now. But remember, it's a wild ride. One minute everything works, the next you're staring at undefined is not a function and questioning your life choices. Still, for anything web-related, JavaScript is king. Love it or hate it, you can't escape it. In fact, the video player you're watching right now, the comment section below, the like button you're about to click, all JavaScript. TypeScript. TypeScript is what happens when JavaScript goes to therapy. By the early 2010s, web apps were massive. What started as small scripts to animate buttons had turned into full-scale apps with thousands of files. And JavaScript was letting developers ship bugs to production like it was their job. That's when Microsoft stepped in with TypeScript. It wasn't meant to replace JavaScript. It was meant to fix it. The core idea was simple. Add static typing. In plain terms, TypeScript checks your variables, functions, and parameters before the code runs. If you accidentally pass a string where a number should go, TypeScript tells you right away instead of letting your website crash during a live demo. That single feature changed everything. Large-scale JavaScript development suddenly became manageable. You could spot mistakes instantly, document your code automatically, and let your editor auto-complete everything with confidence. TypeScript compiles down to regular JavaScript, which means it runs anywhere JavaScript runs, browsers, servers, mobile apps, and even IoT devices. There's no performance penalty because what ships to the user is still plain JavaScript. The impact was huge. Frameworks like Angular, Next.js, and React all added first-class TypeScript support. Google, Slack, Airbnb, Asana, and Microsoft now use it across their front-end and back-end systems. It's become the default for any serious web project. By 2025, surveys show that over 40% of professional web developers use TypeScript in production. Rust. Created by Mozilla in 2010, Rust had one mission: deliver C++ performance without the C++ disasters. Rust is a systems programming language, which means it works close to the hardware, but with one critical difference: safety comes first. The secret is Rust's borrow check. Checker, a system that enforces memory safety at compile time. It tracks how every piece of data is accessed, ensuring you never use invalid references or create race conditions. Here's the Rust experience. You write code, the compiler says no, you fix it. The compiler says no again, you fix it again. The compiler says no 47 more times. But once it finally compiles, you know it's rock solid. Rust has topped the most loved language survey for 8 straight years. Not because it's easy, but because once you master it, you never want to go back. Rust delivers the speed of C++ with the security of a managed language. Mozilla originally used it to rebuild parts of the Firefox browser, improving both stability and performance. Since then, Amazon, Microsoft, and Dropbox have all adopted Rust for performance-critical components. Even the Linux kernel, which was written almost entirely in C for over 30 years, officially began integrating Rust support in 2022, a massive milestone for software safety. Rust also shines in concurrency, running multiple tasks at once without letting them interfere. Where C++ might allow 2 threads to corrupt the same memory, Rust simply refuses to compile code that unsafe. That makes it ideal for modern workloads, cloud computing, game engines, and blockchain systems where one crash could mean real money lost. The learning curve? Steep. Developers often say Rust is like learning to think differently about programming. Less improvisation, more discipline, but once mastered, it's empowering. You write code that's both fast and trustworthy. Rust has topped the Stack Overflow Most Loved Language Survey for 8 consecutive years, and its community is growing fast. C, the foundation. C isn't just a programming language. It's the godfather programming language, the one every other language either learned from, stole from, or is still paying tribute to. C is the reason your phone works, your car starts, and the Mars rover didn't crash into a rock. Born in the early 1970s at Bell Labs, C was created by Dennis Ritchie to rewrite the Unix operating system, which up to that point was written in assembly, basically programming in raw machine instructions. Painful, tedious, and one typo away from frying your system. C changed that. It offered the speed of assembly with the readability of English-like syntax, which was revolutionary. Suddenly, developers could write portable code, programs that worked across different machines without needing to be rewritten from scratch. That one idea, portability, made C unstoppable. By the 1980s, it was everywhere, powering Unix, forming the base of Microsoft Windows, and even influencing Mac OS decades later. If you've ever used Linux, you've used C indirectly. The Linux kernel is almost entirely C. The Python, Ruby, and PHP interpreters, written in C. Even modern browsers like Chrome and Firefox rely on C for their rendering engines. Why? Because C talks almost directly to the hardware. No virtual machines, no garbage collectors. When you write C, you're practically whispering into your CPU's ear. You decide how memory is used, when it's cleaned, and how every byte moves. That control is exhilarating and dangerous. Forget to free memory, you've created a leak. Right past an array boundary, you've opened the door for hackers. Entire cybersecurity breaches have started with tiny C mistakes, like the Heartbleed bug in 2014, caused by a simple memory handling error in OpenSSL, a C library used by millions of websites. It exposed private keys, passwords, and sensitive data across the internet, all because of one unchecked buffer. But that's the trade-off. Power and precision come with risk. C gives you total control and zero forgiveness. Yet, that's why it endures. C is used anywhere performance matters. Operating systems, databases, embedded systems, game engines, and network drivers. If you're running a router, a smartwatch, or even a Mars rover, there's C code humming beneath the surface. It's not beginner-friendly, and it definitely won't hold your hand. But learn C and you'll see how computers really think. Every modern language, from C++ to Go, Rust, and even Python, owes C a debt. It's not just a foundation, it's the bedrock the digital world was built on. Go, or Golang, is what happens when Google engineers get tired of waiting for their code to compile. Their goal? Build a language that's fast, clean, and doesn't make you want to throw your laptop out a window. It's not flashy. It's not trying to be clever. It just works. Fast, stable, and predictable. Docker, the tool that revolutionized how we deploy software, written in Go. Kubernetes, the system that orchestrates millions of containers, also Go. Companies like Google, Uber, Dropbox, and Cloudflare use it for services that need to handle millions of requests per second without falling apart. Syntax-wise, Go is clean and strict. There's one way to do things and the compiler enforces it. That consistency means teams can collaborate without debating code style for 3 meetings straight. It compiles blazingly fast, deploys easily, and the binaries are tiny. No dependency nightmares. No works on my machine drama. Just run it and go. Developers love it because it just gets out of the way. And there you have it. 8 languages that power nearly everything you touch. Now here's the thing. You just learned what languages run your code. But do you know what hardware actually executes it? Because what's the point of writing perfect Python if your CPU is bottlenecking at 100% and you have no idea why? That's exactly what we're covering next. Every computer component explained simply. CPU, GPU, RAM, motherboard, hardware actually executes it. 8 languages that power nearly everything you touch. Now here's the thing. You just learned what languages run your code. But do you know what hardware actually executes it? Because what's the point of writing perfect Python if your CPU is bottlenecking at 100% and you have no idea why? That's exactly what we're covering next. Every computer component explained simply. CPU, GPU, RAM, motherboard, all of it broken down so you actually understand what you're buying. Click the video on screen right. Motherboard. The motherboard is the foundation of your PC.